All right, so today we are going to talk about Oxy Fuel Welding and some of the equipment that's in there. Now, we're already going to have gone through some of the equipment, so this hopefully will kind of reiterate some things and just give you a little bit more of a sense of all the equipment that kind of goes along with the Oxy Fuel Welding and really kind of the cutting as well. There's some differences that we'll talk about in future classes when it comes to the cutting equipment. Basic setup of a gas welding outfit is kind of what you see here on the screen. You're always going to have an acetylene tank. You're going to have an oxygen tank. That acetylene could be another fuel source like a natural gas or propane. We'll talk a little bit more about those things as we go down. But very typically, you're going to see acetylene because of the price of acetylene. It's one of the cheapest gases that we can use for an oxy fuel welding outfit. We've got to have some regulators that are going to be attached to those things. Those are specific to oxygen tanks and specific to acetylene tanks. You're going to have hoses that are going to lead into those things. You'll notice that there are green and red hoses. Those are color indicators that we always use to help make sure that we don't mix things up and we don't swap like an oxygen with an acetylene. So you always see oxygen with the green hose. You always see acetylene or your fuel source with a red hose. That's all going to lead up into a little torch body where we're going to have a welding tip on the end of those things. There's going to be some valves that are in place there, and then some other safety features that we'll talk about a little bit later. A lot of stuff that we have in the shop, it runs off a manifold system. So the tanks are actually separated out. They're actually in a different room. We can turn those tanks on. We can supply the whole manifold system. And each of those manifold systems is going to have a little torch that's going to be attached to that. And that's what you guys are going to be welding on is with those little torches. The tanks aren't going to be right next to where you're at with a manifold system. But really, it's essentially the same process there. So there's a couple of things about the valves or the tanks that we really need to be kind of concerned with. One, when we're dealing with the oxygen tanks, okay, these valves are going to be something that is going to seat at the bottom when it's closed, and then it's going to seal at the top when it's all the way open. And so on these valves, on oxygen valves, you want to make sure that you open those valves up all the way. And that's what's going to make sure that we don't have gases leaking out of this system because it could cause an issue. We don't want to have oxygen leaking out for the sake of just losing money or just adding oxygen into the environment, because especially when we're dealing with flames, oxygen is going to add into a flame and make a flame bigger. And that's kind of what we're trying to do, but in a controlled manner. If you look at the valve here in this picture, this is where our regulator is going to be tightened into. And on these oxygen tanks, they are a high pressure tank, so they can have pressures that can go up to like 2,400 PSI. They do have these little safety buttons on these, okay? Essentially what these things do is if the pressure gets too big within that tank, this valve is going to open up. It's going to release some of the oxygen. As the air heats up, we have a tank that's sitting outside, sitting in the sun. The air in that tank is going to expand, much like it does on a tire. If you drive on tires, the pressure in your tire is going to go up. Same thing is going to happen in here. And with 2,400 PSI inside of that tank, sometimes if it heats up too much, that tank could explode. So these little safety devices are designed to make sure that it doesn't kind of explode the tank and it releases the pressure out. All tanks, whether it's an oxygen or an acetylene, you want to make sure that you're chaining those things up or that they're locked in somehow into a cart, or if it's on a wall, it's chained up to the wall to prevent them from falling down as they go through. So with the manifold system, like what we have, you basically have an oxygen tank. It might be multiple tanks in some instances. That's kind of what we have here. There's a couple tanks that are actually running that whole manifold system, running all of the units that we're going to be working with. So there's one tank, and then it runs down a line that's going to feed each individual area. They're going to have master regulators at the beginning of that, and we're not going to mess with those things. We typically just let those things set up, be as they are. And then what we do is we will adjust each regulator at your station. So those are going to be the things that are going to be important, is to make sure that you are focused on what your pressure is at your station. So there's multiple regulators that are in line with a manifold system. The master one controls the overall pressure. So we tend to set that one a little bit higher. So that way we can have pressure inside of the other ones that can match that and can do that. If we have 12 different stations, we're going to need enough pressure to run those 12 stations. So we'll kick that one up a little bit higher. The ones that you're going to be messing with are the regulators at your actual station. And that's where we can increase, decrease as we see fit. These tanks should have labels on them. They should be labeled oxygen. You will see it if you see it on the tank. You will see things that say acetylene, so you can identify what type of gas is in there. If we don't see a label, don't use that gas, okay? But most of the time, it's going to be pretty obvious. And most of the companies do a really good job of keeping them up to date, making sure that the labels are on there. If not, we can return it to the supplier. The acetylene tanks, these are the ones that we're going to be probably a little bit more concerned with because the acetylene is the fuel that we're going to be using within this system. The fuel is going to cause that to actually have a fire. The oxygen aids in that fire being a little bit hotter, almost like blowing on a fire as we start to, start a fire. We can add air into that, and that's going to help make that fire burn hotter. It's doing the same thing, but in a very controlled environment. Okay. Acetylene, there's a couple things that we need to kind of worry about, and we really don't need to in here because we're not drawing off so much acetylene in this class. But if we were running big torches, big tips, and we were pulling a lot of the acetylene, we can only pull about 1/7 of that cylinder's capacity in a 1 hour period. Okay, we are not going to be anywhere near that. There's actually like 2 or 3 tanks that we're going to be pulling from. So we're not going to go anywhere near that. But if we were to remove all of the acetylene from that in a very fast-paced time, it could cause that cylinder to explode, okay? Some things that come into effect is the temperature of it, how many cylinders we have, how much is left in that cylinder. But these acetylene tanks are highly, highly flammable, okay? In fact, acetylene, I think it has it on here somewhere. Let me look through. Acetylene actually has a pressure that it will explode at at 30 psi. So if you get it to 30 psi, basically most car tires, if you get it to 30 psi, that acetylene can explode just under its own pressure. So some of the things that we do with these acetylene tanks is we actually add an acetone inside of the tank. These are not a high pressure tank. These tanks, we run about 350 psi inside of them, and that's more than 30. But what happens is the acetone and a little foam element on the inside actually encapsulates the acetylene and prevents it from actually exploding under its own pressure. Okay. We have flashback arresters, we have water seals, we have regulators with control valves, all those things that are done to help make sure that we don't have a fire or a flame go back into there. And there's tons and tons of different safety systems in place to help prevent that. Because of the unstableness that acetylene is, we never set a regulator above 15 psi. The main regulator that we have on our manifold system, we'll probably set that to like 13 psi. And then at your stations, we're going to run them at 5 psi. We can kind of up that or drop it down depending on how we need for our welding processes, but we never want to run it above 15 psi. Regulators actually have a red line where it will show you, hey, don't go above this stuff. And your regulators at your stations will not be able to go above that because the main one will not be above 15 psi. So as far as the safety kind of goes with it, there's a lot of things that are going to be in place to help prevent you from actually like leaking this stuff out, causing a flame, having some issues. We're going to have some stuff. You might have already experienced some things in the welding, but we're going to have some things that are going to come, that are going to happen. But it is a pretty safe process, even though acetylene is very highly flammable. Copper, silver, mercury, those things, we want to kind of stay away from those things a little bit because they can form explosive compounds. Acetylene is a very heavy air. You are going to smell that. In fact, you probably will have already smelt acetylene, so you'll know what it smells like. But you don't want to be in a confined area with a bunch of acetylene because it's heavier than air and it can cause you to suffocate. We're going to be in a well-ventilated shop. We don't have to worry about that stuff at all. The regulators that we're going to attach to these tanks, there are really kind of 2 types of regulators that we're dealing with. There's a single stage regulator and a two-stage regulator. Which one we use really kind of depends on how accurate we want our pressure to be. Single stage regulators are going to come in. The pressure is going to basically increase, but its ability to adjust and maintain that pressure isn't as good as a two-stage. A two-stage, there's actually two components, two areas where pressure comes in, and it helps give you a more balanced, better PSI, better holding capacity. We may have one or both of these things in there. Two-stage regulators are more expensive than single stage. You may only have a single stage regulator at your station there, especially with the manifold system, but the pressures are going to be pretty well balanced. There's not going to be that big of a difference when we see that stuff. So like I said, the two-stage ones are considered like two regulators in one because there's basically, like it's like the name states, there's two stages that actually goes through to help make sure we could maintain that stuff. Okay, we reduce that high pressure down, and that the second stage gives us what we call our working pressure, or that flow to that torch there. The master service regulator on the manifold systems that we have, those are typically going to be a little bit larger because they're having more flow that's going through those things with that manifold system. They're better able to handle the large volumes of gases than what we have with maybe just a standard small one. Okay. There are two, if we'll go back to this little picture here. On these regulators, there's going to be two different pressure gauges that you are going to see. One is going to be your high pressure gauge. That's the one that's always closest to where the tank is. So this is where we connect our tank to. Our hose connects down to here. This regulator right here is going to tell you how much pressure you have left in your tank. This is going to be different. This one's an oxygen one than the acetylene. Acetylene is going to have different readings because they don't go up to that 2000 PSI. Okay, so you're going to see a different reading on here. It's a different regulator altogether. The pressure or working pressure or hose pressure is going to be this regulator right here. You'll notice the numbers are a lot smaller on this one. To adjust that pressure up or to decrease the pressure, you need to turn this screw in to increase or back it off going counterclockwise to decrease it. If you want to decrease it, okay, or you want to increase it, the best thing to do is actually have the hose that's attached and turn on that torch and let that stuff flow. If I were to have it closed off and I were to back this off to reduce the pressure, it's going to maintain whatever pressure is within that line. So if you open it up, you can let some of the oxygen, some of the acetylene out, you can get a better reading on that regulator there. The line regulators, those are the ones that we have with the manifold systems past that main regulator that we have. Those ones you may only see one gauge attached because we're not reading tank pressure on those things. If it's just one gauge that's attached to it, it's going to give you your working or your hose pressure, okay, for your system. Okay? And I'm not sure off the top of my head which one we have, but you guys will get used to that as we see it. So if it's just one, it's going to tell you hose pressure because the tank pressure is going to be on that first main regulator in line. The hoses that we have attached, I mentioned that we have different color coding systems. Red is going to be acetylene or fuel. In our case, we're using only acetylene, so that's all we're really worried about. But you see these terms, oxy fuel, oxyacetylene, they are interchangeable to an extent. Oxy fuel means that we're doing oxygen and some sort of fuel source, where oxyacetylene is specific with the fuel is going to be acetylene. You will see these things marked with an OXY or an ACE. That's going to indicate that those fittings are to be attached to oxygen parts or to the acetylene parts. There is, I may have it somewhere else. On these things, there are markings. There's actually notches in the acetylene nuts on the hoses, indicating that they are what we call left-handed threads. Oxygen regulators, oxygen hoses, those are all right-handed threads, meaning that you have to go righty-tighty, lefty-loosey. The acetylene ones are going to be reverse. You cannot mix and match because the threads are going in the opposite direction. It's another way for us to prevent these things from getting interchanged with each other and allow us to make sure that we're hooking them up to the right port. Most of these things are already going to be hooked up. we don't have to worry about doing that. But understand that there is a notch in them. The acetylene is left-handed threads, okay? The oxygen is right-handed. With the hoses, one thing that we want to make sure that we're careful of is that we're not making contact with the flame or any hot metal. We don't want to kink those things. We want to make sure we have a good gas flow. We're not building up more pressure than what we need. And anything that might be falling during the welding process, people stepping on them, things like that, we want to prevent that stuff as much as possible. Okay, so making sure that you're just aware of those hoses, aware of what's going on there. That's going to help make sure that we don't have any issues with that. Now, the welding torch that we use typically is what we consider a positive pressure torches. These ones are nice because they can draw off more of the acetylene within a system and still function and operate correctly. This is typically what we see on these welding torches. You are going to have your torch body that's going to have your valves from both your acetylene and your oxygen. One thing to note, these valves, counterclockwise is going to open up both valves. These are not reverse threads for the valves. It's only on the threads that the hose is attached to. You're going to have your oxygen hose, your acetylene hose that's going to go up into that system. If we turn these things on, gas will flow into our mixing chamber. From our mixing chamber, it's going to go into our torch tip. We can light that with a striker, and then we can adjust our pressures. We can adjust our flame accordingly. We mentioned it the other day, but these nuts on these welding tips are hand tight. You are not going to wrench them down with any kind of tool. There is an O-ring that seats these things down that will prevent gases from leaking out of here. If it does leak out after tightening it, we may have an issue with the equipment. We'll have to take a look at it and fix it, but we should never have to wrench these things down. You want to be able to change these tips out for different welding processes. You want to go from an aught to a 1 to a double aught tip. Okay, we'll talk about the sizes of tips here in a little bit. So the positive pressure torches, they allow you to kind of burn, create that flame, to melt that metal, to actually complete that welding process. Okay. The hand valves are going to be used to get your fine tuning, how much acetylene, how much oxygen. What we're trying to do with this is to get what we consider a neutral flame. So we want a flame that just has enough acetylene and enough oxygen to be neutral. Okay. In class, we're going to show you how we actually do that. And I think maybe we have a video that you're going to see as well that will show you how to actually adjust it. It's hard to kind of identify it without just kind of seeing it. The torch orifice must be an actual size. That's why we have different tip sizes come in at each of your stations. There are different tip sizes that you can swap to depending on what type of weld joint that you are making, depending on the thickness of the metal. Those sizes come in different pieces or different numbers. The bigger the number, the bigger the orifice is. Okay. So if we have a double aught tip versus an aught tip, the aught tip is going to be better. We say aught, it's 0. Aught is just the term that is used. We don't say 00. We don't say 0. We call it an aught tip. Don't ask me why. That's just kind of industry standard. From the aughts, you go to the 1s, which are bigger, 2s, 3s, 4s, 5s, 6, 7, 8. You can go up pretty big. Most of what we're going to be using, probably up to a number 1 tip, maybe a number 2. But number 1 and below is typically for the thickness of metals that we're dealing with. That's typically what we're going to do. There will be some stuff. Sometimes we get debris and different things in there. We may have to clean those things out. If that's the case, we'll use tip cleaners to actually do that. But that's kind of where that combustion takes place. That's where that flame actually comes out. And that's what we're going to be welding with when we do that. So the welding tip cleaners, depending on the orifice size, depending on the size of the tip that you're using, you're going to have to find the right size tip. You don't want to have a lot of resistance. It's basically just a small round file that goes into the tip of that, and it just cleans out any debris that might be on the outside or just on the inside. As things kind of pop, sometimes it will kind of clog that stuff up there. So there's all sorts of different tips on there, and we can use those things to kind of clean. There's a broach tool used to shape that hole. We can kind of clean off, kind of flatten it down. Or you can use a drill bit, but tip cleaners, they're a little bit easier to use. So a drill bit of the right size can do the same thing. When we are welding, you have to have a minimum of a shade 3 lens. So a lot of times auto darkening helmets will have a grinder function. Those things typically have a shade 3. Typically what we see is maybe a 4, a shade 4, or a shade 5. If you looked through those goggles, you would kind of see a green tint to things. That's going to help kind of protect your eyes. There is a little bit of a UV rays that come off of these things, but it's not as bad as like a shield metal arc welding or other processes that we do. So we do have to have some sort of goggles. Shade 3 is the minimum. Shade 5 is the recommended. A lot of times you might see a clear lens that goes over them. I have some glasses that are actually a shade 5 cutting glasses. So they're just like safety glasses, kind of like what we see here, except they're already shaded to kind of help protect your eyes. So in either case, we have to have something that's going to protect. In this case, you can look at this student right here. They've got a face shield. That face shield, you can kind of see a little bit of that green tint in there. That green tint is the shade that we need for Oxy Fuel Welding. Because he has those on, he's going to have safety glasses on underneath. Now, his glasses are shaded. That might make it a little bit harder for you to see. But if you have a full face shield like this, you always have to have primary protectors, which are your safety glasses, and then your secondary protector, which is the face shield to protect your face. This is going to be different when we get into shield metal arc welding, where we're going to have a welding helmet. We're going to have a welding helmet. You're going to have glasses on. If we have goggles that completely surround the eyes, there's no need to have the safety glasses because they're going to be protecting your eyes. But if it's a face shield like this or a welding helmet, you're going to wear safety glasses. Protective clothing that needs to be on. Hands should be protected. Leather gloves, the welding gloves. If you got your own, or if we have some, those are going to be things that are going to kind of help you. Gauntlet type would be fine. Sometimes, they have elastic bands. You want to be careful about that though, because elastic can kind of melt to your skin. Jackets made of leather or any kind of other fabric, even just like a jacket can go over a sweatshirt. That's enough to kind of protect you. Something that's not going to be flammable or catch on fire very easily. Leather may get a little bit hot, but protecting your arms from, any kind of burns or from a little bit of the UV ray is going to help. Trousers, no cutoffs. You're going to have metal that's going to be, molten metal that's going to be coming down. You don't want to, have stuff where your pant legs are cuffed up and it's going to be like a little cup that's going to collect any of the hot metal. That can cause a fire, can cause your leg to catch on fire. When we're using handheld torches, we never use a flame to light a torch. No matches, any kind of combustible materials, any kind of spark that goes in your pocket, anything like that can cause damage to you. So we use a striker, which creates a spark. That's what's going to light it. Each station has their own striker there. That's what we use. Never a lighter, because a lighter could blow up in your hand if you go in the wrong spot. Not a good idea. Oh, some of the supplies that we need. Okay, one, we need welding gases. Okay, obviously we've talked a little bit about that stuff already. You need a welding rod. Depending on the material, you might need a flux to go onto it. And then the other thing that we need is a fire brick to help retain some of that heat. So some things that you would find, the fire bricks are going to be on all those tables. That's essentially what we're welding on. That brick is going to help retain heat. We don't want to use just a regular brick because regular bricks are going to pop, explode. We want to use something that's designed for a high heat system. So acetylene, like we said, is the most common fuel that we use in Oxy Fuel Welding, but other gases that we can use could be hydrogen. We see an LP, liquefied petroleum, either a propane or a butane. We see a lot in those, especially in cutting areas or in industries where they're doing a lot of cutting. They may use propane because you get a hotter burn, a cleaner cut. It's more expensive than acetylene, which is why you typically don't see it as much. You can also use a natural gas. It's got a little bit lower heating point, a little bit lower melt, it doesn't get as hot as acetylene or propane. And so it's not widely used, but it is a fairly cheap gas and sometimes can be plumbed directly in. If you're within the city limits, you might be able to just use a natural gas with those systems. Now, on these systems, there's these things what we call check valves. Check valves are used to help prevent the reverse flow of gases within those torches. Okay. On here, you can see we have an oxygen and an acetylene. And on the acetylene, like we mentioned, the notches that you see, these notches indicate that that's for acetylene. They are left-handed threads, or the oxygen does not have those notches. Check valves allow gases to flow in one direction, but not flow in the reverse. So we can't have oxygen going into our acetylene or vice versa. That's one of the things that these check valves are going to prevent. How a check valve works, if we look at this image that we see here, if we have our gas flow coming right in this direction, this little spring and a little disc, might be just a rubber disc, that is going to get compressed. Gas is going to be allowed to flow past that into your torch, allowing you to do what you need. If we have higher pressure going in reverse, so if that pressure goes down, what happens is this spring is going to seal this little valve disc against this part and prevent that gas from flowing in one direction. You are going to get tested, and I'm going to tell you right now, there is a question that asks, how much do we turn a check valve on? Check valves, you do not turn on. They are going to function on their own. There's no valve that you turn on or off on a check valve. They just function. They put them in line with that hose, and they just do its thing. One thing I don't think that I've mentioned, oxygen. We are going to open those tanks up all the way. Acetylene, we're going to go about a half a turn. Sometimes it's a little bit more than a half a turn, but we turn it on about a half a turn, so that way we can shut it off very quickly if there is an issue. So we always take our acetylene valves, we always just crack them open about a half a turn to get them to work. If we do have a flame or a fire that does come back into the torch, okay, we have flashback arresters, which are kind of a check valve, but then they also have sensing capabilities to make sure that these are going to shut off any of the gas flow. So if it senses that a flame is going to come back, these flashback arresters are going to eliminate that flame by basically cutting it off from that tank, making sure that that flame does not travel all the way back. There are multiple flashback arresters. Sometimes the check valves and flashback arresters are in one. Sometimes we just have check valves and then have flashback arresters as we get more near the tank, different parts of the hoses. There are multiple of these systems within the place to help prevent fires from coming back. So like I said, it can be kind of dangerous, but with these safety systems, safety features, it really helps it out. The torch body that we have, you can see some of these things actually have flashback arresters built into the torch body. So if I have a flame that wants to come back into my acetylene, they will stop right there. There's also other ones that are going to be in line on the hoses as well. So there's redundancies built in. These torch bodies are designed for acetylene and for oxygen, okay, to allow those things to open up. Now, we can put welding tips at the end of these torch bodies. We can put cutting attachments. We'll talk about cutting and how we do that and the different processes, how it's slightly different from Oxy Fuel Welding. But we can put basically any kind of tip that we want onto our torch body. It allows us to be more versatile in kind of what we're doing. The welding rods that we have for Oxy Fuel Welding, we basically are going to be using a filler rod. So you're going to have a rod that's going to be in one hand, you're going to have a torch that's going to be in the other, and you're going to be feeding that rod in, dipping that stuff in. You could have just a mild steel. That's most of what we're going to do in here. I think actually everything is going to be mild steel, but you can do Oxy Fuel Welding on cast iron. You can do stainless steel. You can do braze welding alloys. You can weld with aluminum. You don't see a lot of these other processes done with Oxy Fuel because TIG welding has kind of taken over the industry a little bit more. They're a better process. You get a more accurate weld. You get more consistency, better heat control. But you still do see quite a few mild steel, especially in gas line industries like PG&E. They still do quite a bit of Oxy Fuel welding. Most of what we're going to focus on in here is going to be mild steel rods. For those things, the AWS, the American Welding Society, has designated an RG45, RG60, RG65. These are the most common types of rods that we see. They're basically going to allow us to have different types of tensile strength. So an RG45 has 45,000 pounds of PSI. that means it's 45,000 pounds of force to pull that rod apart for every square inch. So if I had a square inch of that rod, it would take 45,000. If I go to a RG60, it's 60,000 pounds, and RG65 is 105,000 pounds. I don't know how they got that numbering system. Different styles. Most of what we're going to be using is an RG45 for the thin metal that we're going to be welding on. That's more than sufficient. And it's really kind of the same process, no matter which one we're doing. It's just the overall result or strength of the weld is going to be stronger. If we need to use a flux, that's going to help prevent any kind of oxides, materials, things like that are coming in. We would have either a separate flux that we would dip that rod into, or it might have a flux on the actual rod. Like if we're brazing, typically we might see a white coated rod. It's going to give you like a golden kind of color. I don't know if we have brazing as a part of the class here. Yeah, we do have one braze joint that we have to do. So we'll talk a little bit more about brazing, and that's going to have a flux that's already going to be on that. If we're doing any kind of silver alloys or any kind of stainless steels, we would also need fluxes on there. For the mild steel, there's no flux needed. It's just a copper coated rod, and we don't have to worry about dipping or doing anything like that. The fire bricks are heat resistant bricks. Again, these are special bricks and stones that are used for that. So the same thing that you might find in like a fireplace or like, a fancy barbecue, like a pizza oven. They're designed to withstand that hot temperature. We basically form a tabletop using them. You're going to weld on top of them. We don't need electricity. We're not using electricity, so there's no need to have metal on metal. We don't have to worry about the electrical flow. So we use those bricks to help retain heat. It helps in preheating, stress relieving, and protects any kind of combustible materials that we might have around. But they're special bricks that are used for the welding process. Now, any of these parts that we're going to put onto here, there is not going to be any kind of thread sealing that we need. If we are going to use that, if we were putting a manifold system together, you want to make sure that you're using a non-oil based type of sealant. There are special sealants that we have for like gas lines in your homes that are non-oil Teflon tape. You can put those things on. Most of the components that we have in here do not require any kind of thread sealant. There's going to be rubber O-rings. There's going to be joints that the way these things are designed that they don't require that. So we don't have to, not like plumbing, we don't typically have to put any kind of sealing compound on those threads to help make sure that they're not going to leak. There's different systems in place to help prevent that stuff from happening. All right, that's all I have for you guys today.